Hello everyone, welcome back to my channel. I am R. Varshita, graduating in Shrivenkeshwara College of Engineering. I am belonging to Department of Basic Science of second semester. Today's subject is mathematics and topic is about bisection method. Bisection method. In mathematics, the bisection method is root finding method that applies to any continuous function for which one knows two values with opposite signs. The method consists of repeatedly bisecting the interval defined by these values and then selecting the subinterval in which the function changes sign and therefore must contain a root. It is a very simple and robust method, but it is also relatively slow. Because of this, it is often used to obtain a rough approximation to a solution, which is then used as a starting point for more rapidly converging methods. The method is also called the interval halving method, the binary search method, or dictonomy method. The bisection method is applicable for numerically solving the equation f of x is equal to 0 for the real variable x, where f is continuous function defined on a interval a comma b and where f of a and f of b have opposite signs. In this case, a and b are said to bracket a root since by the intermediate value theorem, the continuous function f must have at least one root in the interval a comma b. At each step, the method divides the interval in two parts by computing the midpoint c is equal to a plus b divided by 2 of the interval and the value of function f of c at that point. If c itself is a root, then the process has succeeded and stops. Otherwise, there are now only two possibilities: either f of a and f of c have opposite signs and bracket a root, or f of c and f of b have opposite signs and bracket a root. The method selects the subinterval that is guaranteed to be a bracket as the new interval to be used in the next step. In this way, an interval that contains a 0 of f is reduced in width of 50% at each step. This process is continued until the interval is sufficiently small. If f of c is equal to 0, then c may be taken as the solution and the process stops. Otherwise, if f of a and f of c have opposite signs, then the method sets c as a new value for b, and if f of b and f of c have opposite signs, then the method sets c as a new a. In both cases, the new f of a and f of b have opposite signs. So that method is applicable to this small interval. Iteration tasks. If the input for the method is continuous function f and interval a comma b, and the function values f of a and f of b, the function values of opposite sign. Each iteration performs these steps. First one, calculate c, the midpoint of the interval. C is equal to a plus b divided by 2. Next, second one, calculate the function value at the midpoint f of c. Third, if convergence is satisfactory, that is c minus a is sufficiently small or f of modulus f of c is sufficiently small, return c and stop iterating. And fourth, examine the sign of f of c and replace it either a f of a or b f of b with the c f of c, so that there is a zero crossing within the interval me is equal to bfe. Characteristics Bisection method. The characteristic bisection method uses only the signs of a function in different points. Let f be a function from R to RD to R for some integer d is greater than 2. A characteristic polyhedron, also called as admissible polygon of f, is a polyhedron in R having two vertices such that in each vertex v, the combination of signs of f of v is unique. For example, for d is equal to 2, a characteristic polyhedron of a f is quadrilateral with vertices a, b, c, d such that f of a is equal to minus, minus, that f of a is less than 0 and f2 of a is less than 0. Like that, sign f of b, f of c, and f of d, they are equal to minus, plus, minus, and plus, plus. A proper edge of a characteristics polygon is an edge between a pair of particle that the sign vector differs by only a single sign. Here is an example about bisection method. Question is, determine the root of the given equation x square minus 3 is equal to 0 for x belongs to 1, 2. And the solution is f of x is equal to the equation x square minus 3 is equal to x square minus 3. And first you substitute in the x place 1. And again you substitute 2 in x place. And the next, then given function is continuous and the root lies in the interval 1, 2. Let t be the midpoint of the interval. T is equal to 1 plus 2 divided by 2. Then that is the answer is t is equal to 1.5. In f of 1.5 means you substitute 1.5 in x place. Then the answer is minus 0.75, that is less than 0. And again you assume a is equal to t and b is equal to t. F of t is negative. So a is replaced with the t is equal to 1.5 for the next iterations. The bisection method for root finding. It is used to find approximate root of x of a particular function f of x, f of x is equal to 0. The bisection method, also called the interval halving method, the binary search method, or dichotomy method is based on the Bolzano's theorem for continuous functions. The given function f of x, the bisection method algorithm works as follows. Like two values are chosen for which f of a is greater than 0 and f of b less than 0. The interval halving a midpoint is c calculated by the arithmetic mean, and the function f is evaluated for the value c, and f of c has the same sign as f of a. And if f of c has the same sign as f of b, we replace b with c, and we keep the same value for a. And it is equation is n greater than or equal to log b minus a divided by e whole divided by log 2. The pros and cons of the bisection method. There are some advantages and disadvantages of pros and cons. In engineering mathematics, a variety of tools and techniques are available for the problem solving, among which the bisection method is notable example. This method is fundamentally an iterative algorithm designed to reduce uncertainty and yield relatable solutions when identifying the roots of an equation. This is about bisection method. Thank you for watching my video.